Number 18, we know when we graph an exponential, we are looking for what that asymptote is, that line we cannot cross. On this one, we do have it being added or subtracted, which is -5. Okay, which means at -5, 1, 2, 3, 4, 5, right? We have this line that we know we can't cross. And then we're just plugging in easy numbers. We know exponentials grow fast, so we want to start small. So 2 times 3, up caret -1. And then we're going to subtract 5 off. So that gives us -4.3 repeating, or -4 1/3. Then we're going to plug in 0. That gives us -3. Then we're going to plug in 1, which gives us 1. And then we'll plug in 2, which gives us 13. 13 is unfortunately too big, so we need to pick a smaller value. 3 is going to be too big, 4 is going to be too big, so we can pick -2, right? I need to pick smaller than -1. That gives me a -4.7 repeating. And we know, right, it just is what it is. We have to do our best when we're graphing these. So -1, 1, 2, 3, 4 and a little bit. -2, 4 and a little bit more. 0, -3, and 1, 1. Right, here's our swoop. We can't cross this -5, so we're coming straight across here, and then we're going up. Number 19, suppose a football player kicks a ball and gives it an initial upward velocity of 44 feet per second. The starting height of the football is 3 feet. We represent this with, if no one catches the ball, when will it hit the ground? So if we want to determine when it hits the ground, right, if we imagine this as a graph, we have this parabola going on, hitting the ground is over here, that is an x-intercept. We find x-intercepts by solving. And one of the ways we can solve is with the quadratic formula. Okay, so the quadratic formula, if you forget it, is -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is -16, b is 44, c is 3. So -44 plus or minus 44 squared minus 4 times a, which is -16, times c, which is 3, all over 2 times a, which is -16. Okay, so we're going to calculate underneath the square root. Okay, that gives us a 21/28. So now we're going to take the square root of the 21/28. Now, it's not a perfect square, but remember, in story problems, we're ready for a label, and we don't talk about time in feet as a square root. So we're going to use the decimal approximation, right? We're rounding to the nearest hundredth, so 2 decimal points. So we'll have -44 plus or minus 46.13 all over -32. We then need to calculate both options. Option 1, we'll do -44 plus 46.13. Okay, that gives us 2.13. And then we'll divide that by -32. So that gives us -0.07 when we round. And we'll do -44 minus 46.13. And then we'll divide that by -32, which gives us a positive 2.82 when we round. Okay, negative seconds, negative time doesn't work. So when will the ball hit the ground? At 2.82 seconds. B, when does the ball reach its maximum height? Maximum height is at the vertex. We'd find the vertex up here by doing -b over 2a. Okay, so -b over 2a is going to be -44 over 2 times -16. So that gives us a -44 divided by a -32. I'm just putting that in a calculator, okay? And if we round to the nearest hundredth, that'll be 1.38. 0.8 seconds. Now, what is the maximum height? That is also part of finding our vertex, but now we want the y value. So we need to take this answer we got in B and we need to plug it back into the original equation. So we're going to take negative 16 times 1.38 squared plus 44 times 1.38 plus 3. Okay, so I'm just typing this in my calculator, 1.38 squared plus 44 times 1.38 plus 3. And again, when I round, I get 33.25 feet. Okay, I know this label's feet because it's talking about height. Okay, and up here, my labels are feet and seconds. Number 20. The height of a certain insect in feet that jumps straight up into the air is modeled by, right, it gives us that general formula, where t is time in seconds after the insect jumps, and v is the initial upward velocity. Write an equation that can be used to find the height of the insect if the insect's initial upward velocity is 2 feet per second. So this is basically just asking us to plug in this velocity value of 2. It's an equation, so we have to have an equal sign. So h equals negative 16t squared plus 2t. Okay, then we want to know how long until it reaches the ground. So I know the majority of you are going to pick the quadratic formula, but there are other options. Okay, you could solve this by factoring and factor out a GCF, but I will show you the quadratic formula because I know that's what most of you will do. So A is negative 16, B is 2, C is 0. So we'll say negative 2 plus or minus the square root of 2 squared minus 4 times A times C all over 2a. Okay, so if we do underneath the square root, we get 4. Still in the square root. Okay, the square root of 4 is a perfect square, so we get negative 2 plus or minus 2 all over negative 32. And if we calculate both options, negative 2 plus 2 is 0. 0 divided by negative 32 is 0. Negative 2 minus 2 is negative 4. Negative 4 divided by negative 32 is 1/8, or as a decimal rounded, it's 0.13. We need the positive option. So 0.13 seconds.